Hi guys, today I wanted to do another video on yet another cheap power supply. Since I was so disappointed with this Huaco power supply, I was looking to buy a second Lavolta power supply, but I had to wait quite a while until I found a decent offer. And here it is. I got this Lavolta BPS-305 power supply for 30 euros including shipment to my door. And because it was a good deal, I just bought two of them. So let's open up the packages and see what we got inside. We get the manual, we get the mains wire, the probably pretty craptacular load wires, and of course the power supply itself. The packaging looks quite decent, and I'm somewhat confident that the power supply survived the trip undamaged. If you remember, this Huaco power supply arrived damaged because of very poor design choices. Yeah, here it is. It looks the same and hopefully is internal the same. Well, at first glance it looks very similar. But it's not exactly the same. Let me grab the old one and compare the two. Well, look at that. They are a bit different. I actually only wanted to do a quick follow-up video, but hey, let's do a review/comparison between the old one and the new Lavolta BPS power supply. Let's call the new one the Mark II. The case itself is almost the same. There are only small differences. The new one is a bit taller. They are almost exactly the same length. The new one is a bit longer, like by half a centimeter. Yeah, they're almost exactly the same width. The first difference is the handle up top. While the old one is made from metal, the new one is made from plastic. The old handle itself is quite stiff and feels very sturdy. You have no doubt it will hold up. The new one is a lot more flexible and it feels nicer to grab, but it doesn't have that solid feeling the old one has. I think it feels more comfortable, and I'm sure it will do the job just fine, so nothing to worry about here. The front panel looks a bit different. I think the new panel looks better. Like these slots up top are a lot cleaner if you compare them to the old one. The display is also flush and not recessed like on the old one. The knobs look better, although there are still no indicators on where you are on the scale. I'll probably have to do something about that myself. The other big difference is this switch in the middle. It looks like on the new one you can enable and disable the output, which is a very good feature to have. The old one just had this switch, which was to reduce noise in low-load applications, but in the real world it was completely useless. So the switchable output on the new one makes a lot more sense. The Mark II doesn't come with a ground bar. The old one came with this ground plate to quickly tie one output terminal to ground. So they saved 0.2 cents on the new model by leaving that out. So you have to use a short wire or something if you need to do that. Let's take a look at the output terminals. I hope they got rid of the strange fine pitch thread they used on the old one and gone with metric M6 or something like that. So this is the new one, this is the old one, and nope, it's exactly the same. The old nuts fit on the new posts. That's very disappointing, because that is a very odd thread pitch, and if you break or lose one of these nuts, you won't find replacements anywhere. Go watch the review videos I did on this topic with the old version. I guess the guys at Lavolta also didn't watch them. The posts are still made out of brass, which is the correct material to use here. The machining looks a bit better compared to the old one, but it's still just meh, like it will do. There is still quite a burr on these posts, and you also have to deburr them like the old posts. I mean, it does feel a bit sharp, it definitely catches your nail. Let's take a look at the back side. There is a bit of a difference here also. The fan is still the same size, 80 mm, but they moved the fan from the bottom corner to the middle, which might hint to some internal design changes. But to be sure, we have to take a look inside later on. I always like a good excuse to tear things down. Let's take a look at the fuse in the mains connector, which is still a 5 amp fuse, which is the right fuse to protect the delivered mains cable, which is a 0.75 square millimeter. This is thick enough for this 150 watt power supply, so once again, no worries here. Let's see if these supplied load wires are actually soldered properly this time, or if they are still the same. Nope, it's exactly the same. Still a cold joint. This is so stupid. I can't believe it. This is still a cold joint. And it's the same awful 4mm banana jacks with these screws on top, which in bad situations can come in contact with each other and cause a short or something, yeah. These plugs are also very bad. So nothing new here. This is still pretty much very cryptacular. Let's see the other one. Let's see if this one is properly soldered. I doubt it, but you never know. Let's test this one. Let me grab that, bring that in focus. And yeah, it's just comes off. It's not properly soldered. Both of them aren't. Well, hey, at least they are consistent. I mean, you try producing reliably cold joints on a regular basis. It may be not as easy as it looks. Anyway, they also moved this sticker from the back of the power supply to the bottom of the power supply. Let's take a look at it here. The sticker on the old version states that this version was launched on June 2016 and the specific unit was produced in December 2016. But the serial sticker on the bottom might say otherwise. I mean, the 16 could stand for the production year 2016 and the 08 might stand for the month, which would be August, and the rest of the digits might be the actual continuous production number. Who knows? Maybe it's just the same number on every unit. It's really not a given that they actually keep track of the produced units with a continuous serial number. On the new power supply, this sticker is at the bottom and it says the release date was January of 2015. Huh? How can that be? So the new version was released before the old previous version. That doesn't make much sense. Something is up here. This is kind of suspicious. I think someone is trying to hide something here. Manufacturing date is supposed to be March of 2019, and if you take a look at the serial number at the back, it states production year 19 in February, and this might be then the continuous production number. So they might actually give each unit an individual serial number, but yeah, who knows. So the serial number says it was made in February 2019, and the sticker at the bottom says it was made in March 2019 and launched in January 2015, so yeah, a little bit suspicious. It still has these rubber feet, which is good, but they feel greasy and smell a bit, so be careful. They might stain your table if you don't put something underneath them. And there are also some not so pretty scarf marks already installed on the bottom of this power supply right out from the factory, so quality control doesn't care about the bottom side, I guess. One other thing I noticed are the slits for cooling airflow. On the old one they are all the same. But on the new one there's something strange going on. On the right panel, this side, they are all fine, just like on the old one. But on the left panel they are all over the place. Look at this. At the back of the power supply they seem fine, but towards the front they are all misaligned. Shorter on one end and then longer on the other, and at the bottom row you can clearly see that the distance between the slits is not the same. This one is thicker, this one is thinner. This one is once again thicker, thinner, thicker, thinner, thicker, thinner. I think that during production they had to punch this piece of metal twice. I don't know why they didn't do it in one go, probably to save on tooling costs, or it wasn't really feasible to do it in one punch, but it looks like they did all these slots in 2 punches. So they probably built a punch die with 15 slots per row and punched it twice, and one of the punches they slipped past the end stops and I got this mess. I would like to take a look at the second unit and to see if it's exactly the same or if it's just this one unit. Let's take a look at the second unit I ordered, and on this example the slots are properly aligned and everything looks fine. So there is nothing funny going on here like on this one. So this was probably like a production slip-up and quality control didn't flag this, and yeah, you see their standards aren't that high. I mean, this will have no negative effect on the cooling performance, it's just an appearance issue. A bit sloppy, maybe somebody just had a bad day at the factory and thought, it will do. But I'm very curious, if you got one of these power supplies and if you experienced some quality issues, please let me know in the comments below so we can have a discussion about the quality of these power supplies. Now let's get to the business and tear it down. I'm really curious to see if they also changed the internal design. And let's take a look. And wow, look at that. It looks quite nice inside, I have to say. I'm pleasantly surprised. It looks completely different to the old version here. The power board was completely redesigned. It's this board now. It's also a lot smaller. Look how big this is and how small this one is. So they redesigned the whole power board and everything looks quite tidy and clean. I mean, the old one was a bit messy, soldered wires everywhere. In comparison, the new one looks so nice. Wiring is done with connectors everywhere, here and here, at the top and here. And the wires are zip tied together and everything just looks clean and orderly. It's so much better than the old design, which is a bit messy if I'm honest. This time the rectifier is mounted directly to the heatsink. I like to see that. In the old design, the rectifier was just screwed down to the bottom plate and was used at its thermal design limits. So this will definitely improve the longevity of this part. They also changed the packaging of these power transistors. They did use a liberal amount of thermal compound for the transistors, but none for the rectifier. They could have also used it on the rectifier. It wouldn't harm it. I mean, come on, you're already in here doing the same work, just swipe a third time and use it for the rectifier. I mean, there's probably enough on here that you can scrape off and put under the rectifier, but yeah. But this time they didn't isolate the transistor electrically from the heatsink. Looks like the heatsink is mounted to the board to isolate it. But be careful when you open this during operation. This heatsink will carry a potential. There is a slot in the heatsink, and if you look right underneath it on the board, there is an empty space, and on the board it says RT1. So maybe this version was designed with a temperature-controlled fan in mind, but they left it unpopulated, probably to save on production cost. Oh, and look at that, there are some unpopulated pads near the fan connector, and the silk screen and the traces are quite telling. It looks like here we may have a voltage divider to scale a temperature signal, we have place for a Zener diode to reference it, a place for an SMD transistor to control probably a power MOSFET or something which would go in here. This looks very promising. I have to dig a bit deeper to find out what is actually possible here. But it doesn't look that difficult to install the missing parts. And who knows, maybe just with a few parts you can have a temperature-controlled fan on this power supply. Who knows, maybe I'll make a video about it. Subscribe if you don't want to miss that. One thing you shouldn't do is use your caps as a heatsink. This will not help them live longer. Quite the contrary, heat kills them faster. So this is a very poor design choice. Don't use your caps as heatsinks. Just bend the tab back a little bit. And that's half as bad as it was before. The second one is also touching. They're right at each other. Just bend it back and that's almost fixed. Yeah, don't use your caps as heatsinks. And on the second unit, they couldn't decide which way to do it. Push it right to the cap or leave an air gap in between. So yeah, they're not quite sure what to do here. If you get one of these, just push the transistor back so there's an air gap and the cap isn't directly heated by this heatsink. Just leave a small air gap and it will probably be fine, but this is not the finest design choice you can make. These will probably be the voltage regulators which provide the supply voltage for the power board, like plus or minus 15 volts, and it would be better if you give them a heatsink or provide free air so they can be properly cooled. Cooling them with the cap is really not the way to go. This is a very poor design choice, just bad. Don't ever do that. Talk about planned obsolescence. Engineers would never do that. Shh, nobody needs to know. The caps themselves are from Jiahui. I never heard of them, but they will probably be just good enough like everything else. The board itself looks quite good. The soldering job and the placement of the parts is also decent, so there's nothing obviously horrendous going on in here. And on the back side it seems like the pins are ground down. There is a bit of a burr on their edges, they catch your skin. This was probably done to prevent the pins from poking through the wires at the bottom of the power board, because the power board is placed on top of the wires, and if you have these sharp pins poking through, you can puncture the insulation and make a short. Grinding them down is a solution, but leaving a sharp burr isn't, because if you expose this power supply to vibration, these burrs can actually cut through the insulation of these wires anyway. In a vibration environment, this may actually cause a short if one of these burrs on these pins cuts through the insulation of one of these wires. So they should have used some sort of a separator in here between the board and the wires, but hey, they saved it. I mean, this isn't that great. I think they should have routed the wires properly. You really have to be mindful with using this power supply in an environment with high vibration loads. The soldering job looks okay, but there is a lot of flux residue left on the board, so the cleaning process wasn't that thorough. It's like the whole board is covered in it. I don't see any revision or production date markings on the board. Maybe they are hidden beneath the heatsink over here. They did use the proper flathead screws to mount the heatsink to the board, so no issues here. And let's take a look underneath. Here we go. So this is probably the part number, and we have a revision. So this board is from the 15th of August 2017. All in all, I do like this power board a lot. It's a lot smaller and cleaner than the previous generations. And except for the mistake of mounting these voltage regulators directly to the caps, and the missing parts for the temperature control of the fan, and the missing thermal compound underneath the rectifier, but otherwise you can't be too critical of this part. So I like this version a lot better than the previous generation. Now let's take a look at the display board, and I noticed they only used 3 screws to mount the display board, although they had 4 in mind. They probably thought, well, 3 is enough, let's save the 4th screw and save like 25% of the cost for mounting the display board. I do like that. 25% is not a bad cost saving here. Not bad at all. And hey, why not only use 2 screws like this, and you can save also this one, so you save another 25%. And Lavolta, you can use this cost saving technique also on the mount of the transformer, like mount the transformer only with 2 screws, and also the fan in the back would also be doable with only 2 screws. Another 2 cents saved here. But let's take a look at the other supply I got. Maybe this is just a one-off. The second unit also only has 3 screws, so this was by design and not just an accident. Nice job. And the new display board also looks a bit different from the old display board. This is the old version, this is the new version. The old version has a lot more parts, so let's take a look at the new version and figure out what's going on in here. This is the new display board. So this board revision was made in 2018, probably on the 6th of December. You can take a look at the back. So power must be this connector, signals must be this connector. And you can also see both sides for voltage and amperage are also completely divided, and the function is pretty straightforward. You have each a rectifier, then a voltage regulator, some buffer caps, some voltage dividers for scaling and offsetting the incoming signal, and then the analog to digital converter with display driver. Something interesting also, they left the break-off tabs on the board. You can clearly see this was designed to break off after production, so they saved this production step to save on costs or something like this. But this is odd. These look like programming headers on this board, so this means those might actually be microcontrollers and not the legendary ICL 7107 analog to digital converter with 7-segment display driver. And both chips are coated with some resin or something like that to protect them from dirt and moisture, maybe from small solder blobs like this left over from production, so this one can definitely fly off and short some pins on here. The markings on these chips are really hard to see, but it looks like those are actually Nuvoton microcontrollers. Precisely the N76E003AT20-834HDFI. I quickly searched them online and it looks like those are 8-bit 16 MHz 8051 cores with 1 KB of RAM and 18 KB of flash, and also a 12-bit analog to digital converter. And one of these micros actually costs only 30 cents. Microcontrollers these days are cheaper than dirt. I mean, the cheapest ICL 7107 I could find would cost me $3, like 10 times more than these microcontrollers. That's incredible. So the Mark II uses microcontrollers to display the amperage and the voltage. Yeah, another upgrade. The pins on the backside are once again ground down. You can actually feel a burr catching your skin. And once again, as you can see, it wasn't cleaned all that thoroughly. There's quite a bit of residue left on that board also. Let's take a look at the trimmer board. This is the part number, and revision looks like to be the 1st of March 2017. And as you can see, it is properly mounted with these tabs to the side here, one on each side. And also the trimmers are properly mounted with a lock nut, so nothing funny going on in here. And I expect this to work properly, not like the Waco power supply, which arrived dead because of very poor design choices. And I expect no issues here. So yeah, good job. There's not that much to that board, just a few trimmers and this switch to engage or disengage the output. So I don't want to take out this board, it's just too much hassle. And finally we have this little board for the output posts. And as you can see down in here, this is from the revision of 5th of February 2018. It has this big diode in reverse polarity, probably to clamp down reverse currents from inductive loads. And down in here a few capacitors for smoothing probably. The ground wire looks like an American gauge 20, yeah, which is enough for 5 amps. But the wires from the transformer are American gauge 18, as you can see right there. The on-off switch feels fairly solid and is rated for 8 amps and 250 volts, so this is good enough for this application, and I'm sure it will survive. But once again, the heat shrink wasn't properly shrunk down. I can move it with my finger. Yeah, you can see it's not properly shrunk down, it's just stuck on there. So if you disassemble it during operation, you have to be mindful. There might be some spots where 250 volt potential is exposed, so yeah, just be a bit careful. Although it is once again very clear that they cut a lot of corners in here to save on production costs, I really like this Mark II of the Lavolta BPS-305 power supply. Construction-wise, it is definitely an improvement over the previous generation, and you don't have to modify it right from the box to make it last, so that's also a plus. So I'm gonna put it all back together and see how it works, but this will be it for this video. I'm gonna do the function tests in the next video, so if you have any questions or comments, leave them in the comment section below. If you liked this video, please give it a thumbs up, and if you would like to see more videos like this, subscribe to my channel. Thank you for watching, and I'll see you another time. Bye!